We would like to have Excel perform for us an analysis of variance. That's called ANOVA. So let's move on to high school samples. And to use the add-in, we need to be sure we have it activated. So in the help box here, I just typed add for add-in. I click it and be sure you check analysis toolpath. Now let's go to the data tab, data analysis. And from here, let's choose ANOVA single factor. You might need to scroll up and push OK. What is the input range? We have these scores, the sample SAT scores from 3 high schools. We're going to select from the top, selecting also the labels. So I go from there, Control Shift, I can use the right arrow to select, let's stop there, and the down arrow to select everything. So let's take a look. It looks okay. Now they are grouped by columns. You see them in columns, and we have the labels in first row, and the alpha should be 0.05. That's correct. The output range, where we want to place them, so suppose we want to place them right here next to our data, so let's put like F5 or something and push OK. Let me adjust these columns. So I'm going to highlight them and just double click in between. The summary, these are just simple functions you can use separately on your own, but they are created by you by ANOVA single factor analysis, which is really cool. So the count would be how many we have for each high schools. You can use the count function. The sum is just the sum function. So if you have the sum for all the high school one, it's going to give you this. If you have the average, it's going to give you this. And that would be the variance. If you remember the variance, it was the var s because we have a sample. And if we want to try this for high school 1, Control Shift down, enter, and you see how the numbers match. Let's take a quick look at the ANOVA table, which is right here. So we have over here the sum of squares, which tells you how far the data observations are from the mean, and we have that between groups, so between high school 1, high school 2, high school 3, and also within each of the groups, so within each of the high schools here. And if you add them up, you're going to get the total here. Now, DF means degrees of freedom. For between groups, the formula would be, we have 3 groups, so the formula would be 3 minus 1, so you're going to get 2 degrees of freedom. And for within groups, because we have 50 per high school, 50 times 3 is 150, minus 3, how many groups, is going to be 147. Added up, you're going to get 149. And then we have the mean squared. What is the mean squared? It would be the sum of squares divided by how many degrees of freedom we have. So if you have this number divided by 2, you're going to get this number here. The F ratio would be the mean squared between groups, so this number, divided by this number over here. And you're going to get 0.56. Now the next value, which is very important, is the p-value, the probability of the population being similar to the sample. And we got 0.57. So 0.57 is less than the alpha. If you remember when we did the ANOVA, we selected alpha 0.05. So because it's less, then it means that there is a natural variation in the test scores and no relationship between test scores and locations. So it doesn't matter if you are in high school 1, high school 2, or high school 3. And then we have the F critical, which used to determine if the F test is significant. Now, because F critical on the right side of F, that's exactly what we want. So we have the same conclusion that there is no relationship between test scores and location. Let's move on now to Combined Score Samples worksheet, where we have SAT scores and absences. And we have a hypothesis. The more days of school missed by a student, the lower the student's SAT scores. And we would like to test that, creating a covariance matrix. Let's see how we can do that. We can go again to the Data tab, Data Analysis, and this time let's use covariance. And let's push OK. For the input range, we're going to select SAT scores, absences, and also the labels. So let's select labels and Control-Shift down arrow. And this time, if you notice, we have a population. So it's not just a sample, it's a population. They are grouped by columns, and then the labels are in the first row. As for the output, suppose we want to put it right here in H3. So I'm going to type it in, and let's push OK. And let's see what we got here. If you look over here at the SAT, that's the variance for population, okay? And it's calculated automatically for you. And then you have the variance in population for absences. And finally, you have this negative relationship. So we got our hypothesis confirmed. The more days of school missed by a student, the lower the student's SAT score, because we have the negative relationship. Let's create now a histogram. So we can go to the Data tab again, Data Analysis, and we would like to create a histogram for absences. So let's click on Histogram, OK. And for the input range, we're going to select D4, D153, so that those would be all the absences. For the bin range, we're going to select the bins over here, F4, F6. So these are the bins. 0 means we have 0 absences, 5 means we can have 1, 2, 3, 4, 5, and 10 means we can have from 6 to 10 absences. And we'd like to have the output range H8, where we're going to place our histogram data, the table, and also the chart. So be sure to check chart output and also cumulative percentage. Now let's push OK. And I'm going to just move the chart here, and let's make more room for the columns. So we have 12 students who never missed a class, and then we have 57 students who missed from 1 to 5 classes, and then we have 81 students who actually missed more than 6 through 10 classes. And that's the cumulative. So if this is 8%, cumulated 12 plus 57, so that would be 46, and all these together, that makes it 100%. Okay, and you can see that with the orange line over here, that's the cumulative. And the blue columns would be the frequencies. We'd like to see now what happens if someone misses more than 10 absences, up to 15 absences. And we're going to create what is called a forecast sheet. To do that, let's go ahead and first sort smallest to largest by the absences over here. So we're going to sort by absences, smallest to largest. We're going now to select SAT scores, absences, labels, Control-Shift down to get all the scores and all the labels. And then we can go from the Data tab, we have a forecast group over here. And let's click on forecast sheet, and we want to end at 15 absences. And then let's push create. Let's show some markers on this chart. So I'm going to use a style that has markers like this one. I don't want to see those grid lines. And I'm going to just move this chart and resize it a bit. And let's see what we have. So this is what happened, and this is the forecast. Now for the forecast, you're going to have an upper limit and a lower limit. And this is basically, so it should be in between these bounds. And if you look at the numbers here, you can see how the SAT scores, so these are the SAT scores that were recorded, and these are the predicted ones, and these are the bounds. Okay, so probably it would be around this, but it can also be as low as this and as big as this. Okay, but what you notice is that these scores are simply going down, and they keep going down. And this would be a negative score, so that doesn't make sense, but you get the point. So if you're going to have more absences, then lower SAT scores.